Here is a matching type question. Study the items in both columns carefully. Try to work out the matching before we solve it together. Let us begin solving this step by step. We apply IUPAC nomenclature rules systematically to each structure. A. The longest chain is 9 carbons, nonane. Numbering from the end that gives lowest locants to substituents. C2 has a methyl group, C5 has an isobutyl group, CH2CH, CH3, CH3, which is to methyl propyl. Giving locants 2 and 5, from left versus 5 and 8, from right, left to right numbering wins. Name 5 to methyl propyl, 2 methionine is equal to 5 isobutyl 2 methionine. B. The longest chain is 8 carbons, octane. Numbering shown goes CH7. Methyl at C7 is equal to C2 from other end, methyl at C4 side chain which is a propyl group, CH2CH, CH3. CH3 is equal to but actually counting the side chain, CH2CH, CH3. CH3 is equal to isobutyl. Re-examining, the branch is CH2CH, CH3, attached to main chain giving propyl with methyl is equal to isopropyl. The answer states 4-propyl meaning the side chain is N-propyl, CH to CH to CH3, and methyls at 2 and 7. Name 2,7-dimethyl 4-propyloctane. C. Longest chain is 11 carbons, undecane. Methyl at C3. The branch at C6 is CH2CH, CH3, CH, CH3, CH3 is equal to 2,3-dimethylbutyl. Name 6,2,3-dimethylbutyl, 3-methylindecane. D. Cyclohexane ring. The drawing shows gem-dimethyl at 1 carbon plus methyls on 2 adjacent carbons. Assigning lowest locant set 1, 1, 2, 6 tetramethylcyclohexane. E. Cyclohexanol ring with OH and gem-dimethyl. Numbering to give OH C1, methyls appear at C2 and 2 at C1, 1 is part of gem arrangement, actually the structure gives 2 methyls at C2, gem and 1 methyl at C3 with OH at C1. Answer 2, 2, 3 trimethylcyclohexane 1 ol is equal to 2, 2, 3 trimethylcyclohexanol. F. Bicyclic looking but is cyclopentane with methyls at 1, 2, 4 positions. Name 1, 2, 4 trimethylcyclopentane. G. Bicyclo 3.1.1 heptane skeleton 7 carbons, bridges of 3, 1, 1 carbons between bridgeheads. Methyl substituent at C2. Name 2-methylbicyclo 3.1.1 heptane. H. Same bicyclo 3.1.1 heptane skeleton with methyl at C2 but drawing differently. Name 2-methylbicyclo 3.1.1 heptane. I. 8 carbon chain octane. At C2 2 methyls, gem. At C6 2 methyls, gem. At C7 1 methyl. Total 5 methyl substituents. Name 2, 2, 6, 6, 7 pentamethyl-octane. J. Nonane chain C1, C9. Substituents: methyl at C2 methyl at C3 1 methyl propyl at C4 methyl at C5. The group at C4 is CH, CH3. CH2, CH3 is equal to 1 methyl propyl, not to butyl, since naming as substituent gives 1 methyl propyl. Name 4, 1 methyl propyl, 2, 3, 5 trimethionine. K. The nonane main chain has a very complex substituent at C5. The quaternary carbon at C5 bears 1 ethyl group, CH to CH3, 1 methyl group, and 1 CH, CH3, CH, CH3, 2 is equal to 2 methyl, 1 methylethyl group, making the substituent name 1 ethyl 2-methyl 1,1-methylethyl propyl. Name 5,1-ethyl 2-methyl 1,1-methylethyl propyl nonane. Therefore, the correct answer is A. 5-isobutyl 2-methionine 5-2-methionine 2-methylpropyl, B. 2,7-dimethyl 4-propyloctane, C. 6,2,3-dimethylbutyl 3-methyl-undecane, D. 1,1,2,6-tetramethylcyclohexane, E. 2,2,3-trimethylcyclohexanol, F. 1,2,4-trimethylcyclopentane, G. 2-methylbicyclo 3.1.1 heptane, H. 2-methylbicyclo 3.1.1 heptane, I. 2,2,6,6,7 pentamethyl-octane, J. 4,1-methylpropyl 2,3,5 trimethyl nonane not to butyl, K. 5,1-ethyl 2-methyl 1,1-methylethyl propyl nonane. Therefore, the correct matching is A matches 5-isobutyl 2-methionine 5-2-methionine 2-methylpropyl, B matches 2,7-dimethyl 4-propyloctane, C matches 6,2,3-dimethylbutyl 3-methyl-undecane, D matches 1,1,2,6-tetramethylcyclohexane, E matches 2,2,3-trimethylcyclohexanol, F matches 1,2,4-trimethylcyclopentane, G matches 2-methylbicyclo 3.1.1 heptane, H matches 2-methylbicyclo 3.1.1 heptane, I matches 2,2,6,6,7 pentamethyl-octane, J matches 4,1-methylpropyl 2,3,5 trimethyl nonane not 2 butyl, K matches 5,1-ethyl 2-methyl 1,1-methyl propyl nonane.